Hi, welcome to lesson 4 of solving simultaneous equations by elimination. We're just moving on to the next stage. So firstly, if you can pause the video and have a go at these two starter questions, if I just bring your attention to the fact that we've got other variables used in these questions. So instead of x and y, we have a and b and p and q. And just to let you know that this is perfectly normal and quite common. Okay, so have a go at these questions, please. Okay, let's have a look at the solutions then. So we've been asked to find the solution of 3a plus b equals 11 and 2a subtract b equals 4. So remember, we're looking for the same amount of, in this case, a or b and opposite signs. So what we would do here is we're going to eliminate the b's, and the way we do that is by adding equation 1 and equation 2 together. That will give us a total of 5a, and that equals 15. Divide by 5, so that will be a equals 3. Once we know what a is, we substitute a equal to 3 into one of the original equations. Just choose whichever one you find easiest, so I'm going to choose equation 1. So 3a plus b equals 11 becomes 3 times 3, which is 9, add b, which is 11. So if we take the 9 over, b is 11, take away 9, so b is equal to 2. The solution, therefore, is 3, 2. Remember to double check the solution in the original equations. So if we put 3 and 2 into equation 1, we're looking to get the answer 11. And if we put 3 and 2 into equation 2, we're looking to get the answer 4, which we do. So we know that 3, 2 is the correct solution. If we look at b, we have 4p take away 3q is equal to 15 and 2p plus 3q equals 3. Again, we're looking for the same amount of either p or q and opposite signs, so we're going to eliminate the q terms. We do this by adding the two equations together, which will eliminate the q terms, and we're left with 6p equals 18. We divide by 6 to work out p, so p equals 3. Now substitute that into one of the original equations to work out the value of q. In this case, I'm going to choose equation 2 because I think that one looks easiest. So 2p plus 3q equals 3 becomes 6 plus 3q equals 3. We take the 6 over and we get 3 subtract 6, which is negative 3. So if 3q equals negative 3, then q equals negative 1. So when we have letters other than x and y, we just put them in alphabetical order. So p would be first and then q second, so the solution would be 3 minus 1. Again, substituting p equal to 3 and q equal to negative 1 into equation 1 and equation 2. When we do that, we're looking for equation 1 to equal 15, and that's what we get, and equation 2 we're looking to equal 3. And we also get that as well, so we know that we have completed these questions correctly. Okay, so our learning intentions haven't changed. We're still solving simultaneous equations by elimination, and we still need to understand the method and use the method to find the solution or point of intersection of the pair of equations. Just taking it another stage further. So we need to remember though that before we begin, our objective is we need the same amount of x or the same amount of y in both equations, but with opposite signs. However, sometimes we need to multiply an equation to get this. Let's have a look at an example. So here, example 3, we're being asked to find the solution to the pair of equations by elimination. Equation 1 is 5y plus 4x equals 13. And equation 2 is 3y subtract x equals 1. Now, we want the same amount of x or the same amount of y in each equation, but with opposite signs. So we're kind of halfway there with the x terms because we have the opposite signs, but we need 4x in equation 2, so therefore we need to multiply equation 2 by 4. Now when you multiply the equation, please note that every term in the equation gets multiplied. So when we do this, equation 1 is remaining the same, so we get 5y plus 4x equals 13 for equation 1, but equation 2 becomes 12y take away 4x equals 4. So we just proceed as before, but please note, since equation 2 has changed, we now relabel that as equation 3. So just to recap, we decide which equation to multiply, we decide what to multiply by, and then we follow the same procedure as before to solve for x or y. So let's work through example 3 completely. So decide which equation to multiply, decide what to multiply by, and then follow the same procedure as before. So looking at equation 1 and equation 2, we can see that we need to multiply equation 2 by 4. Equation 1 becomes 5y plus 4 equals 13, so it just stays the same. But equation 2 becomes 12y take away 4x equals 4, and we relabel that as equation 3. Now to eliminate, we just add the two equations together. This will eliminate the x terms and we will be left with 17y equals 17. We divide to find y equal to 1. Now we substitute y equal to 1 into one of the original equations, so I'm going to choose equation 1 because I think that looks easiest. So 5y plus 4x equals 13 becomes, so 5 times 1 is 5, plus 4x is 13. Take the 5 over and take it away. So 4x equals 8, so x equals 2. So our solution is x equal to 2, y equal to 1, so the coordinate would be 2, 1. Remember to double check your solution. So substituting 2 and 1 into equation 1, we're looking for 13 as our answer, and we get that. Substituting 2 and 1 into equation 2, our answer should be 1, and we also get that. So we know our solution is correct. Let's just make sure we've understood that process and try another example. So example 4, this time we have the pair of equations 2y plus 3x equals 12 and 5y minus x equals 13. Exactly the same process. Decide which equation to multiply, decide what to multiply by, and then follow the same procedure as before. So looking at equation 1 and 2, we can see we need to multiply equation 2 by 3. Equation 1 remains the same. Equation 2 becomes 15y take away 3x equals 39, and we relabel this as equation 3. To eliminate the x terms, we add the two equations together. So we get 17y equals 51. Divide by 17 to get y equals 3. Now we substitute y equal to 3 into equation 1 because that's the easiest. So 2y plus 3x equals 12 becomes 6 plus 3x equals 12. If we take the 6 across and subtract, we get 3x equals 6. So x equals 2. So our solution this time would be the coordinate point 2, 3. Double check your answer. So substituting 2 and 3 into equation 1, we would want to get an answer of 12, and we get that. And then substituting 2 and 3 into equation 2, our answer should be 13, and this also matches what we have. So therefore the solution 2, 3 is correct. Okay, now it's over to you. So go to Posts or Files on the team to get today's exercise and answers. Complete your answers into your class jotter. Make sure you show all your working and check and correct your work at the end, please. Thank you.